Let us start the lecture. In this lecture, we are going to discuss about phasor and phasor diagram. First of all, we have to know what is phasor. Here you can see a rotating vector that represents a sinusoidal varying quantity is called a phasor. In the previous lecture, we already know we can write E equal to E naught sin omega t, or I can be written as here E can be written as E naught sin omega t. I also can be written as I naught sin omega t. That means our alternating current and EMF both are sinusoidal varying quantity. And in phasor, here we have to represent this alternating EMF and current, which is sinusoidal varying quantity, as a rotating vector. Then phasor diagram. What is phasor diagram? A diagram that represents alternating current and voltage, what we discussed, of same frequency. Then both current and frequency must have been same frequency as rotating vectors in a plane. Okay. Then how you have to represent that? Let us see. Let uh, let us take some example. First of all, I just take let our E is our E naught sin omega t. Then you can draw this phasor just as like this. This is your axis. In along x-axis omega t. Okay. In y-axis we have both E and I. Get it? E and I both are in y-axis. Okay. First of all, we have to represent E equal to E naught sin omega t. How have to represent? Just here. We have to draw a vector. Okay. And this vector is a E naught. Yes or no? And this angle is a theta. Sorry, theta. This angle is a omega t phase. Okay. Just see. Here, if we draw a perpendicular here, then this becomes E naught sin omega t. And this becomes E naught cos omega t. Yes or no? And let this is our I. Sorry, E. Okay. This is our E, which is equal to E naught sin omega t. Then we have I. Let our I also I naught sin omega t. Then how you can draw this? We have to draw this as just here both E and I have are in same phase. Okay, as the angle is same, so I also can be drawn on this, but just below to E naught. Okay, this is our I. Both are along same line. E and I both are along same line, as there is no phase difference among them. In EMF we have sin omega t, phase is omega t, and in I we have sin omega t also. Okay. Then if we have different phase, that means let us take another example. You have to take E can be written as E naught sin omega t. Okay. Then how you have to draw this? Then along x-axis we have omega t. Along y-axis we have both E and I. Okay. Both E and I. Then to draw equal to E naught sin omega t as phasor, just like this, we have to draw a vector like this. Okay, this is our E naught, and this point is our E. This is the angle omega t. Okay, then if our I is equal to I naught sin omega t minus phi, just here. The phase of E is omega t, but the phase of I is omega t minus phi. That means here I, that means current lag. So the phase of current is less than the phase of EMF. So how we have to draw? We have to draw just like this. Okay, this is our I naught, and this angle is our phi. So which are current lag by EMF. Here we can write, as the phase of current is less, so we can write current lag behind EMF by phase phi. Got it? Then if this is pi by 2, then current lag behind the EMF by phase pi by 2. If it is pi by 4, then lag behind pi by 4. So no. Then let us take the third condition. In third condition, with our E equal to E naught sin omega t. Okay. Then along x axis as it is omega t, along y axis both we have E and I. So we have to draw E naught sin omega t just like this. As like previous, we can draw E naught sin omega t like this. Okay. This is our E naught. This is our angle omega t. If we have I equal to I naught sin omega t plus phi, that means here current I lead the phase, yes or no? Because we have in EMF phase is omega t, but in current we have in current we have phase omega t plus phi. Plus phi means some extra angle is added. That means current lead. That means current go upward. Okay. Then we have to draw current axis just like this. This is our I naught, and this angle is our phi. Here you can write in place of phi, if here we have pi by 4, then we can say current lead EMF by phase pi by 4. Or if we have pi by 2, then we can say current lead EMF by phase pi by 2. Yes or no? And this is our I, this is our E. This is our E naught sin omega 2, which is our E. Yes or no? You got it or not? Then in AC circuit containing only resistor, as here we have AC circuit, that means we have to give the AC input. AC input means here we can write E equal to E naught sin omega t. Yes or no? This input is our E naught sin omega t. Okay, this is our input EMF. Yes or no? Then if I is the current through the circuit, if I can say I is equal to the current through circuit, then from Ohm's law we can write V equal to IR, or here in place of V we can write E equal to IR. In place of E we can write E naught sin omega t equal to I into R, or we can write I equal to E naught upon R sin omega t. As E naught is our peak value and R is a constant value, so this E naught by R can be replaced as I naught, which is our peak value of current. I equal to I naught sin omega t. You can observe this one. One is E equal to E naught sin omega t. Okay, and another one is I equal to I naught sin omega t. Just see here. Here we have EMF has phase omega t and current has also phase omega t. That means there is no phase lag between the current and EMF. You got it? Then how you have to draw a phasor diagram? First of all, just draw a graphical representation. First of all, draw a graphical representation. In graphical representation, just see, we have E equal to E naught sin omega t. Remember one thing, I equal to E naught by R. That means I naught always less than E naught. Remember this one. I naught always less than E naught. Okay. Let's see. This is actually our E equal to E naught sin omega t. As you all know, this is the graphical representation of a sinusoidal wave. Sine wave can represent just like this. Yes or no? And then I naught sin omega t. I also are sinusoidal wave. Yes or no? So, but we have to draw the I naught value just below the E naught value. This is our actually E naught, peak value of EMF. This graph, the dotted line represents I equal to I naught sin omega t graph, and solid line represents E equal to E naught sin omega t graph. So here just see I naught is our peak value. So remember one thing, I naught always less than E naught. Then how you can draw the phasor? For phasor, as we know here there is no phase lag, So first of all, we have to draw the E. Always you have to draw E first. Okay. This is our E naught. This is our omega t angle. This is our E. Okay. Then I also draw on this line, but below to E naught. We can write I naught here. This is our I, and there is no phase lag between the current and EMF. Just remember this one, okay? Then we have AC circuit containing only an inductor, okay? That means in a circuit we have only an inductor and one AC source is there. AC source means here we have to give an input of E equal to E naught sine omega t. First just we have to write here E equal to E naught sine omega t. Okay. Then this is the input EMF. Okay. Then EMF induced in the inductor is, in inductor also some EMF is induced. Yes or no? In electromagnetic induction chapter we have Faraday law. Sorry, in self induction E equal to minus L di by dt. Let it be E prime. Okay. This E prime be minus L di by dt. L is the coefficient of self induction. I is the current flows through it. Sorry, di by dt is the current flows through it for unit time. E prime is the EMF induced in the inductor. Net EMF in the inductor, what we have? E plus E prime. We have to add this. Okay. Then what we got here? In place of E, just write down E. But in place of E prime, we can write down minus L di by dt. As there is no resistance in the circuit, so here this EMF is 0. As there is no resistance in the circuit, so this our upper net EMF is our 0, equal to minus L, sorry, E minus L di by dt is equal to 0. So we can write E as L di by dt. Yes or no? Then see, in place of E, we can write E naught sin omega t. Yes or no? E naught sin omega t equal to L di by dt, or we can write di can be written as 1 by L or E naught by L sin omega t dt. Okay, you got it now. Then let us just find out I. So to find I, we have to integrate on both sides. What you got here? Integration of di, it is equal to okay. Then integration of di is our I. Integration of E naught by L sin omega t. E naught by L is our constant. So just take outside E naught by L, integration of sin omega t dt. Or I becomes E naught by L, integration of sin omega t is our minus cos omega t upon omega. This can be written as I equal to minus E naught by omega L cos omega t. This constant value minus E naught by omega L is called I naught. In place of cos omega t, we can write sin pi by 2 minus omega t. Sin pi by 2 minus omega t. Why? Because you know sin pi by 2 minus theta equal to cos theta. Yes or no? Then what you got just here? We can rearrange this as I equal to I naught. Just take I, sin of minus theta is minus sin theta. Sin of minus theta equal to minus sin theta. Here we have minus sin theta, so we can write sin of minus theta. That means sin of minus theta means omega t becomes plus and pi by 2 becomes minus I is equal to I naught sine omega t minus pi by 2. Just observe this one. Initially we take E is our E naught sine omega t, and here we got I equal to I naught sine omega t minus pi by 2. That means your current lag is no, as phase the phase of current is less than the phase of EMF. So here you can say the phase of current is lag behind the EMF. Okay, here you can write. In inductor, current lag behind EMF by phase pi by 2, or you can also say EMF lead current by phase pi by 2. Okay. Then we have to draw two diagrams. One is our graphical representation of EMF and current, and then our second diagram is our phasor diagram. Okay. Then first we have to draw the graphical representation. This is our graphical representation. As you know, this solid line gives E equal to E naught sine omega t, and the dotted line gives us I equal to what you got here I naught sine omega t minus pi by 2, or you can write also minus I naught cos omega t. As you know, the graph for cos omega t or cos theta is just like this. Yes or no? As here we have minus cos theta, just you can see. As here we have minus cos theta, so you can draw the graph just like this. From fourth quadrant, we have to take the graph. This is a graphical representation, and the phasor becomes, just see, here we have, this is our E naught, which is make an angle, or phase we can write omega t. Then I can be minus pi by 2, means this can lie in fourth quadrant, just below the E naught. This is our I naught, which is rotate in anti-clockwise direction, which is pi by 2. Okay, you can observe here. Here I just wrote I naught in place of E naught by omega L. That is maximum or peak value. So no, I naught is or E naught by omega L. I naught is our E naught by omega L. Then what is our omega L? We know current is our EMF by resistance. Okay. Resistance is opposition offered by the conductor. As here we have inductor, so here we get inductive reactance, which is equal to omega L, or you can write this as E naught by XL, where where XL is our omega into L. Omega is our angular frequency, XL is our inductive reactance. What I say? Inductive reactance. And omega is our angular frequency. L is the self inductance of the inductor. Okay. Omega can be written as 2 pi f or 2 pi nu into L. Yes or no? Here. We can conclude that XL, that is inductive reactance, is directly proportional to nu or frequency. If the frequency of AC increases, then inductive reactance increases. If frequency of AC decreases, then inductive reactance decreases. Okay. Then if we draw a graph versus in that is XL versus nu, then what we got here? If nu is along x-axis, XL is along y-axis, then you can got a straight line here. From this we can say, we know for DC, our frequency is our 0. So our XL becomes 0. That means inductor doesn't opposes the direct current. Okay, direct current passes through the inductor easily. This is all about the inductive reactance or circuit containing pure inductor. Inductive reactance means the opposition offered by the inductor to the flow of current. And another one thing is there, the unit of XL, unit, you must know this, unit, as we know I equal to E by R. Okay, as I equal to E by R. The unit of resistance is ohm. So the unit of XL also ohm. You got it? Then, then we have AC circuit containing a capacitor only. AC circuit means we know we have to give an AC input. So we can write E equal to E naught sine omega t. Yes or no? Just write down this one. In capacitor, we know C equal to Q by V. Yes or no? Or we can write V equal to Q upon C. Yes or no? In place of V here we can write E. E equal to Q by C. In place of E you can write E naught sin omega t for AC. Yes or no? Then this will come. Just remember our aim is to find out I. So just find out here Q. Q becomes C E naught sin omega t. Here we have Q. Then how can we find out I? We know the formula for I is the time rate of flow of charge. So we can write I as dq upon dt. Yes or no? Then see, we have to differentiate the above thing, the wave equation. D by dt of, in place of q, we can write C E naught sin omega t. C E naught take outside as it is constant, and the derivative of sin omega t is our cos omega t into omega. Okay, here we have to use the chain rule actually. Now, first of all, we have to differentiate this sin omega t with respect to omega t. Then we have to differentiate omega t with respect to t. Actually, I use the chain rule. Okay, then here you can get omega c. Just see carefully. E naught cos omega t, or we can here is just like this. You can write E naught by 1 by omega c. Yes or no? 1 by omega c means omega c multiplied with E naught. Okay. Then we can write cos omega t as sin 90 plus omega t. As we know, sin 90 plus theta is equal to cos theta. Yes or no? Then what you got here? Then E naught by Xc. In inductor we have XL. Here we have to take Xc. Inductor XL is our inductive reactance. X or no? Here we have capacitive reactance Xc. Then we can rearrange this sin pi by 2 omega t as sin omega t plus pi by 2. This is our current I. Yes or no? Then just see. Here we got current. Sorry. Just do another next step. Here you can write I naught, peak value, which is our E naught by Xc, sin omega t plus pi by 2. Okay, then just observe this thing. We got I equal to I naught sin omega t plus pi by 2, and we take E equal to E naught sin omega t. Okay, what we take? E equal to E naught sin omega t. Listen, you can observe this one. This is here. Psi E has phase omega t, but I has phase omega t plus pi by 2. That means here current lead the EMF by pi by 2. If the phase angle of current is more than the phase angle of EMF, so here you can say this one, or you can say also EMF lag behind the current by phase pi by 2. Okay. Then we have to draw Phasor diagram, okay. And a graphical representation also you have to draw. So first draw the graphical representation, after then we have to draw the Phasor diagram. Okay. Here this solid line represents our E equal to E naught sin omega t, and as we have in current Here we have cos omega t. Okay, then so we draw the cos graph here. This dotted line is our I equal to I naught cos omega t. Then we have to draw the phasor diagram. This is our E naught. This is our angle omega t. Yes or no? This is our angle omega t. Other than here we know I lead EMF by phase pi by 2. Lead means here the current vector, or as in phasor we know current represents as the rotating vector. That vector is in third quadrant. Okay, as this lead by phase pi by 2, so this is in third quadrant. This is our I naught, this is our pi by 2. Okay, this is actually our phasor diagram. Then very important thing is there, that means here we have I naught is equal to E naught by 1 by omega c, which is our xc. E naught by xc. Xc is our capacitive reactance. Capacitive reactance, that means the opposition offered by the capacitor to the flow of charge. Then our xc is equal to 1 by omega c. Omega is our angular frequency, c is the capacitance. Okay, or we can write also, in place of omega we know the formula for omega is 2 pi nu, or 2 pi fc is there, nu or f, whatever. 2 pi fc. Then from this we can conclude that xc, a capacitive reactance, proportional to 1 by f. Xc proportional to 1 by f. That means capacitive reactance decreases with increasing frequency. So if you plot a graph here, that is if you take a f, first just take 1 by f along x-axis and xc along y-axis. Let f along, sorry, 1 by f along x-axis and xc along y-axis. As you know, we can read this xc proportional to 1 by f in two ways. Either we can say xc is directly proportional to 1 by f, or you can say xc is inversely proportional to f. First of all, you have to say xc directly proportional to 1 by f. Directly proportional means here we have to draw a straight line graph. Okay. Then if we take frequency f along x-axis and capacitive reactance xc along y-axis, then here you can get curve just like this. This is a graph for inversely proportional, or 1 by x, y equal to 1 by x graph. Okay. Then just as you know, for this c, f is equal to 0, frequency is 0. So our xc becomes infinity. So no, xc becomes infinity. That means it opposes the total charge, or you can say capacitor blocks DC. It only allow SC. Unit of capacitance also, or ohm, or you can write ohm just like this also. For capacitor we can write IRMS as I naught by root 2, or you can say in place of I naught we can write E naught by 1 by omega c into root 2. Okay, or you can write ERMS, as we know I naught, E naught by root 2 equal to ERMS by omega c, or this can be written as ERMS by XC. Okay, this is all about the lecture.